Okay, so now I would like to turn to a second system of logic, namely predicate logic, also known as first-order logic. But before we actually get to first-order logic, the question we have to ask is, do we actually need it? I mean, we now have propositional logic. Can't we just make do with what we have? We understand it, it's simple, doesn't it suffice? And the easy answer, I think, to this question is no, it doesn't suffice. It's simply not powerful enough. And the reason for this is that there are certain types of arguments that intuitively are deductively valid, but whose validity cannot be captured by simple propositional means. As an example, consider the following argument. All humans are mortal, Socrates is human, therefore Socrates is mortal. Okay? Intuitively speaking, this argument is definitely deductively valid. If the premises are true, then the conclusion has to be true, we seem to think. However, let's see what happens when we try to formalize this by means of propositional logic. Well, all humans are mortal. There are no propositional connectives there, no conjunctions or disjunctions. So the only thing we can do is we can formalize this using a single letter P. Similarly, for the second premise, Socrates is human, no propositional connectives there, so we're just going to assign it the letter Q. And finally, this also is the case for the conclusion, which we're going to formalize by means of the letter R. So then we formalize this argument as follows. Premises P, Q, conclusion R. Obviously, this is going to be a deductively invalid argument. Okay? And the reason for this, what has gone wrong is that, well, propositional logic cannot look inside the structure of these sentences. Because if you look a bit more closely at these sentences, then you see that they have a lot of things in common with each other. For example, the two premises share the predicate human. The first premise and the conclusion share the predicate mortal, and the second premise and the conclusion share the proper name Socrates. So there's definitely some subsentential, sub-propositional structure going on. But like we already said in the lecture on propositional logic is simply blind to this. It treats the propositions as black boxes, and that means that it cannot recognize the deductive validity of this argument. So what do we need? Well, we need to basically open up the black box and look what's inside. Look at the structure that is inside the proposition. And that's exactly what predicate logic will allow us to do. Now, before we actually get down to business with predicate logic, I should say a bit about why it's so incredibly useful, or about its popularity in general. I think it's fair to say that predicate logic is by far the logic that is most widely used, definitely in mathematics and computer science, but also in philosophy. It's a very important area of logic. For example, Russell's theory of definite descriptions, which is a very important part of philosophy of language, makes essential use of this type of logic, predicate logic or first-order logic. And just to give you an idea, this theory, you might not be familiar with it, but it has often been called the paradigm example of what good philosophy is. So if the paradigm example of what good philosophy is makes use of predicate logic, I think that's a good reason for being interested in predicate logic. So let's get down to business. What is predicate logic about? I think there are two key ideas that you need to understand about predicate logic. The first key idea we already talked about. Predicate logic opens up the proposition and looks inside. So for example, if you have a sentence such as Bob is male, rather than formalizing this simply as the letter P, as we would do in propositional logic, we are now gonna formalize it as M of B. B has the property M, where M stands for maleness and B stands for Bob, of course. But of course, we can also look at two-place predicates or relations. For example, we can look at sentences such as Bob loves Anne, and this will then be formalized as follows: L of the pair B, A. In other words, B stands in the L relationship to A. Again, with L standing for love, B for Bob, and A for Anne. Okay? So that's the first key idea. The second key idea of predicate logic is quantifiers. We're going to introduce quantifiers. There are two quantifiers that we're going to be interested in. The universal quantifier, which talks about all entities, all persons in the domain of discourse, in the universe that is relevant for the argument under discussion, and the existential quantifier, which talks about at least one entity, person in the universe of discourse. So, for example, we can say things like Bob is male, but we can also say things like everyone is male, a sentence which obviously is false in the context of this lecture room. But now I'm just talking about how to formalize this sentence, not about making it true or false, okay? And this sentence, everybody is male, we're gonna formalize as for all x, universal quantifier, mx. So everyone in this room has the property of maleness. Similarly, a sentence such as somebody is male will be formalized as there is an x such that x has the property of maleness. So here we use the existential quantifier. Now the real power of first order logic arises when we now let these two key ideas interact with each other, when we combine them with each other. That means when we start looking at sentences that involve both quantifiers and proper names. For example, we can look at a sentence that involves both the proper name Bob and a universal quantifier. For example, Bob loves everybody. We're going to formalize this as for all x, Bob stands in the love relationship to x. Or similarly, the sentence everybody loves Anne will be formalized as for all x, x stands in the love relationship to A. Or if you want to use an existential quantifier and say things like somebody loves Anne, then we're going to get there exists an x such that x loves A, that x stands in the L relationship to A. But even more exotic, we can also look at sentences with multiple quantifiers. So for example, if you have a sentence with two quantifiers, for example, everybody loves somebody, could almost be the title of a pop song, we're also going to be able to formalize such sentences. Now the point with the sentence everybody loves somebody is that it's ambiguous. You can interpret, you can understand it in two different ways. And predicate logic is powerful enough to understand, to formalize both of these interpretations. The first interpretation of the sentence everybody loves somebody is that for every person in the room, there's going to be another person in the room that is loved by that first person. So for example, I love you, you love him, he loves her, she loves him, etc. Okay? And this interpretation will be formalized by means of the formula for all x, there exists a y such that x stands in the L relationship to y. Now, the second interpretation of the sentence everybody loves somebody arises when there's an idol in the room. For example, Britney Spears or Rihanna or Katy Perry. So then we can say everybody loves somebody and her name is Katy Perry. Okay? So how we formalize this sentence is by means of the following formula. There exists a y such that for all x, x stands in the L relationship to y. Okay? So we have swapped around the quantifiers, and by this we are able to formalize these two subtly different interpretations of this sentence. Again, as was the case with propositional logic, of course, we are not simply interested in formalizing sentences. We want to do something with these sentences. We want to reason with them, make arguments with them. So a typical example of an argument in predicate logic, the one that we started out with to motivate the introduction of predicate logic, is the argument, all humans are mortal. Socrates is human, therefore Socrates is mortal. Now, in predicate logic, this will be formalized as follows. The first premise is going to be, for all x, if x has the property of being human, then he's mortal. Second premise, Socrates indeed has the property of being human, therefore, conclusion, Socrates is going to have the property of being mortal. So how do we deal with these kinds of arguments in predicate logic? Well, the two most important reasoning rules in predicate logic are the ones that allow us to deal with the quantifiers, with the universal and the existential quantifier. The universal quantifier, the universal instantiation rule allows us to get rid of a universal quantifier. So what it says is, for all, if you have a premise of the form for all x, px, then you can conclude p of a. So the intuition behind this is, if everybody has a certain property, then definitely Socrates or whoever you want to invoke here is going to have that property. The second rule is that of existential generalization, and that rule is going to allow us to introduce an existential quantifier. And it goes as follows. If A has a certain property, then there exists an x such that x has that property P. Okay? So using these rules, we can now look at the argument that we just talked about, the Socrates argument. Because what we can do now is we can take the first premise for all x, if x is human, then x is male, and we can apply universal instantiation to it. We can instantiate this universal quantifier by the proper name Socrates, by S. And then we get, if Socrates is human, then Socrates is mortal. Okay? And this instantiated version of the premise we can now combine with the second premise, which said that Socrates has indeed the property of being human, and we can apply to these two sentences our ordinary modus ponens from propositional logic to arrive at the conclusion, namely that Socrates has the property of being mortal. So what we've done here, we have combined predicate logic reasoning and propositional logic reasoning. We applied the rule of universal instantiation to get rid of the quantifier, and once we were at the level of sentences without quantifiers, we did some ordinary propositional logic involving modus ponens. And in this way, predicate logic can basically be understood as kind of an extension of propositional logic. There are also other ways in which you can see that, that predicate logic is an extension of propositional logic. For example, if you look at a universal quantifier, you can basically view that as a very long conjunction. So suppose that there are just three people in the room, A, B, and C. Then if you say that everybody has the property P, that basically means that A has the property B and, conjunction, B has the property P and C has the property P. So a universal quantifier is basically just a long conjunction. In exactly the same way, an existential quantifier is going to be a very long disjunction. Now, of course, this only works when you have only finitely many entities in your domain, but still you can see that there's a very strong connection going on there. And this connection between the connectives on the one hand and the quantifiers on the other can be observed not only at the abstract level of logic, but also in a variety of languages, natural languages from across the globe. And I think one of the best examples here is the example of Japanese. So for example, suppose that in Japanese you want to say Tetsuya or Akira. Okay, so these are just two names of girls. So in Japanese you would say that as Tetsuya ka, Akira ka. Okay, so with the sound ka at the end. Now, if you would want to say in Japanese someone, that is dare ka. So here we see again this sound ka, both to express someone, the existential quantifier, and the disjunction or. Now you might think this is just a coincidence. Well, look what happens when we move to the universal quantifier and conjunction. So suppose that we want to say in Japanese Tetsuya and Akira, that's gonna be Tetsuya mo, Akira mo. Okay? And now you can already guess probably what's gonna happen when we move to everyone. It's not gonna be dare ka, but dare mo. Linguistic observations such as these show that we have a very strong connection between propositional connectives on the one hand and the quantifiers on the other. And that's a pretty cool feature of Japanese. And you can see this not only in Japanese, but in a lot of languages from across the globe.